Hello chemists, we are going to talk about a couple of things to keep in mind when you are dealing with mass spec graphs and commenting on them. First thing to keep in mind is that when you are talking about a mass spec graph, you need to identify at least 4 fragments, of which at least 2 must be the molecular ion peak and the base peak. You do not need to identify every peak present on the graph. In fact, you will not be able to, but you should be able to, working from your theoretical model of the molecule, you should be able to identify at least 4. You probably don't need to do much more than 4, although if you want to do more, the hopes that in case you get a few wrong, you'll have some backup. That's not a bad idea. Second thing is when you are talking about the location of the peaks on your graph, it's tempting to say, for instance, there's a molecular ion peak at 86, therefore the mass of the molecule is 86. What you're leaving off there is units. And you're actually dealing with 2 different types of units. You're dealing with a molecular ion peak at 86 mass to charge ratio, and that means that the mass of the whole molecule is 86 grams per mole. Grams per mole. It is essential to refer to both of those and not to get it confused. The locations on the graph are in mass to charge ratio, 86 m/z, and the mass of your molecule is 86 grams per mole. It's not a peak at 86, and that means the mass at is 86. It means there's a peak at 86 m/z, and this means that the mass of the whole molecule, of the whole molecular ion, is 86 grams per mole. Same with your other fragments here at 29, and also here at, looks like around 57. A good tip is when your molecule breaks, it breaks into 2 fragments. So your molecule up here breaks, you have 1/2 CH3, CH2, and that's got a mass of 12, 24, 25, 26, 27, 28, 29. So that's going to be this peak here. And then you've got the other half of the molecule, which is 57, I believe. So this bit is that peak there. Remember that when a molecule splits, it splits into 2 halves, each of which has a mass. So if I've got a half that's 29, I've also definitely got another half that is 57. Also keep in mind that when a fragment breaks off of the main molecule, it can then break again, which is where the other peaks come from, molecules that have broken more than once. We are only concerned with the fragments that result from a single break, because if we start dealing with more than one break, things get really complicated. So stick with things that only result from a single break. Generally, breaks are more common immediately to one side of a functional group. So for instance, here we've got the oxygen in the ketone right in the middle, and on either side of that we're likely to get a break. You can also have breaks down here. So that would give us 1 fragment at 15. We don't see that here. We would expect to see a peak there. However, absence of a peak is not diagnostic. You cannot say there's not a peak at blah, 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 which means blah. The absence of a peak doesn't tell us anything useful. The presence of a peak, however, tells us that there is definitely a fragment with that mass. Absence of a peak just tells us maybe there was a fragment with that mass and maybe it broke up again, or maybe there was some rebonding that happened. Like, the absence of a peak doesn't tell us anything. That's it. Good luck. I will see you guys soon.